All right, if you will, get your notes titled and dated. Today we are going to talk about the fourth exponent rule. And the fourth exponent rule is the quotient rule. If you recall, the definition of quotient is the answer to a division problem. So all of these problems are going to have a fraction bar, and with fractions, we always would divide the top divided by the bottom. Okay, I'm going to write this in expanded form so that you can see exactly how this rule works. So x to the sixth can be written as x times x times x times x times x over x to the third would be x times x times x. So if you recall from a few years ago, if there's anything on the top and the bottom that is the same, we can cross cancel. So since there's x's on the top and x's on the bottom, we can cross cancel out as many that match. What I mean by that is if I take one x away on the top, I can take one x away on the bottom. So we're going to cancel out as many as we can, okay? So since there were 3 x's on the bottom, I can cancel out 3 x's on the top. So that leaves me with 3 x's on the top and nothing on the bottom. So I'm going to hold my place with a 1. So I can then write x times x times x as x to the third power. So this is my final answer, x cubed, or x cubed over 1. Let's look at another one. So this one is d to the 14th power over d to the 6th. So since they have the same base, let's write it out. So d times d, we're going to write out 14 d's. 3, 4, 5, 6. All right, that's 14 d's, and then 6 d's on the bottom. So as you can see, if we have really high exponents, this could take us a really long time to actually write out all of these. So that's where our exponent rules are going to come into play. So there are 6 d's on bottom, and I know there's at least 6 d's on top. So I can cancel out 6 d's on top and the 6 d's on bottom. So that leaves me with 1, 2, 3, 4, 5, 6, 7, 8 d's on the top. So we would write it as d to the 8th power, and then I'm going to put all that over 1. So d to the 14th divided by d to the 6th could be written as d to the 8th. So since this could be a really long process, writing out all of those bases just so that we can cross cancel, there's obviously a shorter way of doing that. Okay, so the rule for quotient rule is if they are being divided and they have the same base, we're going to keep the base the same, and this time we're going to subtract the exponents. And when we subtract the exponents, we're going to subtract the top exponent minus the bottom exponent. So if we looked at number 1 again, and we have x to the 6th over x to the 3rd, since they have the same base of x, going to take the top exponent and subtract the bottom exponent. So 6 minus 3 is 3. So we got the same answer as we did when we wrote it longhand. So just like on number 2, I would take the top exponent minus the bottom exponent to get d to the 8th. Remember, you can always pause and rewind the video if you need to go back and finish writing out the rule. Okay, but we're going to do a few more examples. All right, so I'm going to write this up here. So we have y 13 x cubed over y to the second. So the y's have the same base. So that means I can take the top y minus the bottom y, which is squared. So I get y 13 minus 2 is 11. So y to the 11th power. And then I don't have anything to combine with the x cubed, so I'm just going to bring that over and put it in my final answer. And then, of course, we can put that all over 1. So we get y to the 11th x cubed over 1 for our final answer. So with the quotient rule, we are subtracting same bases. With the product rule, we were adding them. All right, so let's try this one. So I'm not going to worry about my whole numbers yet. I'm going to bring those over. So I have the same base of a, so I'm going to take the top exponent of 9 minus the bottom exponent of 4. So I'm going to get a to the 5th power. So then the last step has always been, all along, to simplify any whole numbers. So I need to see if 15 over 5 will simplify. You guys can use your ABC button. But I know that 5 will go into 5 one time, and 5 will go into 15 3 times. So this is going to reduce to 3 over 1. But if you guys punch that into your calculator with the ABC button, then you'll get the same answer of 3 over 1. All right, so we have 4 over 2. I'm going to leave that for right now. And I'm going to take the top exponent minus the bottom exponent. Remember, guys, if there's not an exponent there, we can always add a 1. So we're going to take 6 minus 1 and get d to the 5th. And then we need to see if 4 over 2 will reduce, which we know it does. 2 will go into 2 one time, and 2 will go into 4 2 times. So we get 2 over 1. All right, let's try one like this. I'm going to rewrite this up here. All right, so my like basis of d, I'm going to take the top exponent minus the bottom exponent. The reason why I crossed this off, guys, is because I've now moved that 6 up here to the top. So I have d, 10 minus 6 is 4. So I'm done with the d's. And then I have c, 9 minus the bottom exponent, which is 3. So I get c to the 6th. And we can put that all over 1. So the quotient rule is if they have the same base, we take the top exponent and we subtract the bottom exponent. And since we moved it to the top, it's going to stay on the top of our fraction bar whenever we get our answer. Let's do a couple more. All right, so I'm going to take my like bases of A, and I'm going to take 9 minus the bottom exponent, which is 4, and I get A to the 5th. And then I'm going to take the top exponent for B minus the bottom exponent to get B to the 8th. And put that all over 1 so it stays as a fraction. All right, I want you to take a second and try this one on your own. All right, I'm going to go ahead and go over it. I'm going to leave my whole numbers alone for right now. And I'm going to worry about my like bases. So I have C, 7 minus the bottom exponent of 2. So I get C to the 5th. And then my like bases of D, I'm going to take 6 minus 1. To get D to the 5th. And then I have to see if my 6 over 18 will simplify, so you can punch it into your calculator with your ABC button. But I know that 6 will go into 6 one time, and 6 will go into 18 3 times. So that's going to reduce to 1 over 3. All right, so again, the quotient rule is if they have the same base and they're being divided, so they have the same base on the top and the same base on the bottom, we're going to take the top exponent and subtract the bottom exponent to get our new exponent for that same base. As always, if you need to go back and rewind and go back and do a few more examples, you can always do that.